this session, I'm going to explain you a program for fifth experiment, that is multiplication by 2 using bit rotation technique. So that's why here it is written multiplication by 2 means we are going to multiply a number by 2 by using bit rotation technique. Okay. So what happens in bit rotation, I will explain you in detail. For example, if we assume that at this memory location 200A, we have a number that is 35 hexadecimal. I'm assuming that at 200A, we have here I am taking 35 hexadecimal because whatever number we enter, so that number is hexadecimal. Okay. So if we store 35 at this location and here we want to multiply this 35 h means this 35 by 2, then we can use this program. Okay, so first I will explain you assembly language programming, then after I will move on to machine language programming. Okay, so let's start. So the first column, this one, it is given the address, that is the address. So these addresses are also in hexadecimal. So 2000, at 2000 we here we enter the first instruction, that is first instruction, that is LDA. So what this is LDA, that is load accumulator with the content from the memory. So load accumulator with the content means whatever the content is present at this memory location 200A, that we load to the accumulator by using this instruction. So for example, here 35 it is present at memory location 200A, so that 35 it will load to the accumulator. Okay. Then the next instruction given, that is STC, that is set the carry flag. So we know that we have a register, that is flag register, which is used to show different status, means whatever it is the status of the accumulator, so that can be represented by flag register, and inside that flag register we have a bit that is that can be called as carry flag. Okay, so that bit we have to set meaning, so we are whatever it is the present value of the carry flag, okay, or you can say carry bit, that carry bit we convert to 1. Setting meaning whether it is 0 or 1 right now. So if we use this STC, then it will set that carry bit to 1. Okay, so here we set the carry bit, so I'm now drawing the, so here this one I'm representing as the accumulator 1 2 3 4 5 6 7 8. Okay, so since 8085 microprocessor, it is 8-bit microprocessor, so accumulator can store 8 bits only. So and here I'm going to write the carry flag, or you can say carry bit, so that's why CY here. Okay, and this one it is nothing but accumulator. So set carry bit, so whatever it was the value here, so that it will set to 1. Okay, then next given CMC, that is complement the carry flag, or you can say here, so here it is 1, so that it will convert to 0. Okay, so now we have 0 in carry. And then after next instruction given RAL. Okay, so RAL, that is rotate accumulator left involving carry flag. Okay, in the rotation. So first of all, here in the first instruction it was load accumulator with the content of 200A. Since at 200A we have 35, so that we have to load to this accumulator. So this 35 we can write like this. It is 0, 1, 0, 1. Okay, so here 1, then 2 and 4. Yes, it is 20, and this can be written as 0, 0, 1, 1. Okay, so this one is for 3 and this one is for 5. So this is stored at this one, this value is stored at the accumulator. So that's why we can write here 0, 0, 1, 1, and thereafter 0, 1, 0, 1. Clear? That we have in this one. So here this RAL, rotate accumulator left involving carry flag. So we have to rotate left. Rotate left meaning here we have to rotate, and this one it will go this, and here this bit it will go here, and it will come here. Okay, so one bit it will rotate to the left. When one bit it will rotate left, so this 0 it will come here. Okay, and here it will become 1, and then this head was earlier 0. So now you can see this is not the way. I write on first. In another way I am explaining. This 0 it will go here. Okay, so this 0 it will come here. So I am just below I am writing 0, and then this. Okay, this one only it will move here. So 1 it will come here. This 0 it will move here. So this 0 it will come here. This 1 it will go left. So here it will come 1. This 0 it will come here. So here it will become 0, and this 1 it will come here. So here we have 1. Then this one it will go to the left. So we have here 1. Okay. And then after this 0 it will go here. So it will remain as 0. And this 0 it will go here. So here it will remain 0. Okay. So that's here it is happening. So what happened? This 0 it came here. So that's why here it is 0. This carry flag 0 it came here at this place. Because RAL, that is the instruction, that is rotate accumulator left involving carry flag. Okay, here this carry bit it is involved in the rotation process. Okay, so that's what it is going on here, the process. So this one it is done. Then after you see that what happened this one. So when we rotate one bit to the left side involving carry, then whatever result we got, that's what we have to check. Okay, so you can convert this one into decimal also, and then after you will see when you convert this 35 hexadecimal in decimal, so you will get 53. You convert, you can check my other videos also where I have explained how you can convert from decimal to hexadecimal, hexadecimal to decimal, or decimal to binary, binary to decimal, and hexadecimal to binary. So these interconversions I have explained, so you can watch that one also. And here if you convert this in decimal, so you will get this 53 decimal. Okay, that's what you will get. And when you multiply this one by 2, so what you will get? You will get 106. When you multiply this, so 53 multiply 2, you will get 106, that is in decimal. And if you convert this 106 in hexadecimal, then you will see what it will come. So if you convert this one into hexadecimal, so 106 and then divided by 16, so it will come 6 times. Then it will be here 0, and here it will come 1. So 1 0, that is the remainder, and here you have 6 in the quotient. Okay, so this 6 it is So that's why the result you will get 6, and for this 10 you can write on A. So 6A. Okay. So 106, that is in decimal. If you convert in hexadecimal, so that you will get 6A. 6A. That is in hexadecimal. 6A, that is in hexadecimal. And this 6A, you can see when multiplied by 2, then we got 6A. And if you convert this one into hexadecimal, so make this one. So this one you can write down here, this one as A, because this is in decimal, it is 10. So 10 in hexadecimal we can write A. So that's why here it is written A. And if you convert this one into in decimal and hexadecimal, in both you can get here 6. So this is 6. So that's why 6A. So now the result in the accumulator you have 6A. Okay. So that's what it happens here. So the result what we got, when we rotate one bit to the left involving the carry bit, then in that case the result whatever we get in the accumulator, that is the product of 2 and the number which was stored in the accumulator. Means whatever number it was in the accumulator earlier, okay, that is multiplied. That number is multiplied by 2, and then the result we get here in the accumulator. Okay. And then after next instruction given STA200B, this one it is store accumulator content to the memory location 200B. It means we are storing this 6A to 200B. Sorry, by this we get here 6A. Sorry, 200B. We are storing accumulator content. Accumulator content to we got 6A, that we are storing here to 200B. So now we have at 200B 6A. And RST5, that is again to stop the processor to further execute the next instruction, which means the instruction which is present in the next memory address. Okay. So that is the whole assembly language programming for multiplying a number by 2 using bit rotation technique. So this is assembly language. Now for machine language programming, corresponding hex codes, or you can say machine codes, we have to enter into the microprocessor training system. Okay. So corresponding. So for LDA, so I think I should use other color. So now we have here red. Red color I am using for hex codes. So for this LDA, we have hex code 3A. Okay, that is 3A. And for this address, memory address, we enter hex codes in reverse order. It means first we enter LSB, then after MSB. So this 0A, it is LSB, and this 20, it is MSB. So this one it is LSB and this one it is MSB. So first we enter LSB, then after MSB. This is the way microprocessor interprets the memory address. Then after for STC, we have the code that is 37. And for CMC, we have code 3F. 3F. And for RAL, we have code 17. For STA, we have code 32. And again here the address given. So again in reverse order, it means first we write on LSB, then after MSB. So 0B, that is LSB. So first we write on 0B, and then after we write 20. Okay. And for RST5, the hex code it is EF. Okay. So this one now, it is machine language programming. When we enter codes in terms of hexadecimal number or binary, okay, we can enter in hexadecimal or in binary, because when we enter hexadecimal number or a hex code, then that hex code it is converted into binary, because the microprocessor can understand only binaries, not hexadecimal. Okay, it is for us because writing binary bits, it is a little bit complicated, or it makes the understanding a little bit hard, so that's why we use hexadecimal number system. Okay, but microprocessor can understand binary bits in much better way and can manipulate in much better way, so that's why here for our understanding we use hex codes, means hexadecimal numbers, and these hexadecimal numbers ultimately convert to binaries and then processor understand, because there is a circuit in the microprocessor training system. It means because if we don't use hexadecimal and if we try to enter binary bits, then programming will become much more complicated. Okay, and understanding, because we try to ease, we try to make things simpler so that we can understand in a much better way. Okay, so for understanding we use such kind of systems.